Hello, in this video I want to take you along the process of building the PCB for the PiPicoFX device. What you see here is that I'm building a frame to hold the PCB in place while I use the stencil to apply solder paste before populating the board with the SMD components. As a frame, I use older boards I have laying around in my drawer, which all contain stupid mistakes. And since this video is also about failing or making mistakes, I think it's just a good starting point here as an introduction. Well, while you see me building this frame, I'm going to talk about a few things I learned during the making of PCBs. I'm going to talk about a few things I learned while making PCBs. First off is, well, it's always handy to have a lot of test points because they allow you to make additional connection to break out things, or as the name says, to test things. And one thing I didn't apply for this board, but which is I think really handy when it comes to manually populating larger boards, is to number the components starting from left to right, which makes it a lot easier to find a component when you want to populate the board. And then when assembling and testing device, it's always useful to make a test plan, what to test first. For example, maybe just look for shorts before switching on power, for instance, and then check the power supply levels and so on. This not only sort of ensures that not everything just blows up while first powering it up, but it also gives little successes, although maybe the entire board might not be working in the end at all, or might have errors which are too drastic to make it work. And one last thing is, don't expect things to be working right away. At least for me, this reduces frustrations. So, well, here you see me applying solder paste, which took me a while to get this right, but it looks okay now. And then next step was of course to populate the board using SMD part. I really liked this precise work, and this is how the board looks when it was populated, or when most of the parts were there, except for all the external ones. Of course, on the right side you see the support for the PiPicoFX, and here is when I started testing. Of course, I used a oscilloscope and hooked up the Raspberry Pi Pico, and this is the image which is going to appear right now, is the image of the first assembly. You see some pickup wires, I'm going to talk later on in this video about why they're there, and also some external components attached to it. At this point I want to talk about some design mistakes I made, and these were design mistakes that I realized that I made them when I tried to build, or when I built the circuit and checked various sources and various signals and so on. The first mistake, it's already corrected in the schematic, is that I placed the left analog output, which these are the two operational amplifiers that create the symmetric signal. It's actually two inverting amplifiers, and after the first buffer or amplifying stage there's a trace going to the headphone amplifiers, and this originally was behind this decoupling capacitor. This shifts the DC level to 0 instead of the half of 5 volts, 2.5 volts, which are here. But the mistake I made is that the headphone amplifier also has a DC offset of 2.5 volts, which then enter this pin 3 of the XLR connector, and the same on the other side. So what I need to do for the second version of this PCB, of course, is, as already shown here, is place the trace just right after the op amp and then directly connecting them, because the DC offset is the same. This for prototyping, this was easily or more or less easily corrected by just cutting the trace at the right position and then making the connection using thin copper wire. So with some SMD soldering skills, this is easily done. The second mistake was heavier, and this consists of choosing the wrong symbol for this PCM 3060 codec I used. I didn't actually choose the wrong symbol, but the symbol was by itself simply wrong. When I chosen this component, I downloaded it from the internet and checked the first pins and also the last ones, and the number of pins was correct, also the footprint, so I thought, okay, let's go with this. It turned out when I started to test the driver, which switches off and on the oscillator, which powers or which clocks this chip, and when I tried to measure the derived oscillators like the bit clock signal and the left or right clock signal, found out that the signals looked strange. They didn't go all the way to 3.3 volt. They looked somehow like a square wave, but not totally. One thing that could have been is that I maybe roasted the chip while soldering in, but so far this never happened to me, so I thought it's quite improbable. And then I checked this schematic, or checked this symbol against the datasheet, and I found out that especially at the bottom left part, the naming of the pins were just plain wrong. I don't know how this could have happened for this part downloaded from the internet. Maybe it's just from an older revision of that chip, but I cannot really explain. And this symbol up here is the corrected version, which is also included in the KiCad library. And well, unfortunately there's too much is wrong in this board. I cannot really fix all this with cutting traces and using copper wire. Would be too complicated or even impossible, because there's so many fine connections. So I decided, well, we stop at this point. I just have two versions of the PiPicoFX which are useless, or which maybe can be used for other purposes, such as a mic preamp or other just utility things. But well, this is just how it is. I think development always takes iterations and just testing and finding out. So what I'm going to do with the board, which is never gonna work really, is I thoroughly test all the analog parts with respect to noise and spurious signals. This I can still do, and I'm gonna wire the microphone part. Actually, let's go back to this schematic. I wire the microphone output to the auxiliary input, and like this I can at least test the microphone preamp, and also for the hi-hat part I do the same. The one goes on one channel, the other one goes on the other, and this allows me to measure or even use the device as a mic and guitar preamplifier,